Hello guys, welcome once again to Om Institute and welcome to the next session of Super Sundays. Yes, from quite some Sundays we started with this concept of Super Sunday, where every Sunday we are picking up one topic of general aptitude and we are having the practice onto that topic. As we know, general aptitude is more about practice, okay, but this practice dose of practice session doesn't mean that we are only practicing. Of course, we are also learning the concepts and tricks behind solving those questions, okay, so that in all every Sunday one topic is like complete for you. Along with practice, the tips and techniques. Now the today's topic that I have taken, is exponents and log, okay, because in GATE or any other competitive exam also, okay, commonly you get the questions, especially from the properties of logarithm. Some tricky questions can be there, okay, sometimes including the concept of characteristic and mantissa, some tricky questions can be there. So let's learn what is the different variety of questions in this today's Super Sunday for exponents and log. Okay, so exponents, as we all know, exponent, see, normally exponential function is not only e power x, that's a type of exponential function, okay, but yeah, any function of the form a power x is what is the exponential function, okay. So whenever we write down a power x, this x is known as the exponent, this x is the exponent, and a, okay, the number whose exponent is taken, that number a is known as the base. We also call the exponent as power, okay. Now, especially when the power is an integer, okay, when power is an integer, say for example, if I talk about the case of a power n, where n is an integer, then it basically means what? It basically means repeated multiplication of a n times. Okay, so when the power is strictly a positive integer, okay, then this exponent is nothing but the repeated multiplication of the number a, okay, n times. Okay, now if a power x is equal to b, okay, the inverse of exponent we know is logarithm function. Okay, so before I take up any question, just quick important points we are updating here. Okay, so if a power x is equal to b, to eliminate the exponent we take the log. So log to the b, okay, log of b to what base? Log of b to the base a, whatever was the base and exponent, the log b to the base a, okay, will be defined as x, okay, will be defined as x. So x will be given by, okay, the exponent, the power will be given by log of b to the base a, right? Okay, now there are some important cases, like when you take the base e, okay, we also call that log as the natural log, okay, or the Napierian log. Okay, and the base is 10, okay, like you commonly use it in the Bode plot calculations and all, and there we learn also why base 10 calculations are important. Okay, that base 10 is known as common log or Briggs log, and because it is known as common log, see, normally natural log, what is natural log? I'm telling you, log to the log of number b to the base e. Okay, we also commonly write it as ln(b), natural log. Okay, now if you are taking log of the number b to the base 10, we also express it as log b simply. We also simply express it as log b. Okay, not writing any base means it is the common base. Okay, that is base 10. That is base 10. Okay, now, okay, some simple properties. Properties are simple, but that is where, questions will be built up. Okay, so if a power 0 is a, okay, we all know that anything power 0 is 1. A power 0 is 1. Okay, now converting into the log, what do we get? Log of 1 to what base? To base a will be 0. That means log of 1 to any base is always 0. Okay, log of 1 is always 0. Okay, now a power a is equal to a. Okay, so log of a to the base a. Okay, log of a to the base a will be 1. Okay, when the number and the base are the same, the result is 1. Okay, base can never be 1. Okay, base can never be 1. At the same time, log, as we know, is defined only for positive numbers. Okay, log is only defined for positive number. Okay, it's only defined for positive numbers. Okay, that's it. Now, important properties. Okay, this is where, again, questions are built up. Okay, that is log of m into n is log m plus log n. Okay, log to the base a only. Okay, this is base a. This is what is base a. Okay, so log of mn is log m plus log n. Log of m by n is log m minus log n. Okay, subtraction will happen. Log of 1 by n. So what will be log of 1 by m by the above property? Log 1 minus log m. Okay, log 1 is 0. So I only write minus log m. Okay, similarly, if there is, this was the reciprocal of the number m. If there is a reciprocal of the base, log of m to the base 1 by a is also minus log m to the base a. Okay, we can derive it but not required. Okay, let's focus on the practice of exponents and log question. So log m to the base 1 by a is also minus of log m to the base a. Okay, now next, log of b to the base a can also be written as 1 upon log a to the base b. Okay, or more importantly, this is what is more important. log of b to the base a can be written as log b upon log a to any other base c. Okay, to any other base c. Okay, or you can, take that, I can tell you any base c. So let's take it as common base. Common base is log 10. Okay, log to the base 10. So I can also write this as log b upon log a. Simple. So log of b to the base a, sometimes if required, we can write it as log b by log a. Exponent and log are inverse of each other. So a power of log of x will be x. Okay, log to the same base a. Okay, so exponent and log both are having the same base. So they are inverse of each other. So they cancel, answer is only x. Okay, log of b power m to the base a is m log b, is given by m log b to the base a, right? Okay, so when there is the power over the number, it is multiplied outside. Similarly, log b to the base a power m, if there is the power over the base, it is divided outside. 1 upon m log b to the base a. Okay, also coming to the graphs, okay, of the logarithm function. Okay, now the graph of logarithm function log x to the base a, you might have normally seen the graph of, say for example, you might have normally seen the graph of ln x log to the base e. Okay, and must have seen something of this kind. Okay, where I told you log 1 is always 0. Okay, and it's an increasing function. This is ln x. This is ln x. So that is what, whenever you have any base, like here ln x means log to the base e. Ln x means it is like log to the base e, where e is 2.71, which is greater than 1. So whenever you have any base which is greater than 1, okay, log x is an increasing function, okay, for base greater than 1. Okay, but if you have the base between 0 to 1, base can never be negative, na? Okay, so if you have the base between 0 to 1, okay, then the log x is a decreasing function in that case. Okay, so this is what is the graph. So see, log ln x, same graph I've taken here, log to the base 2. Okay, 2 is also greater than 1. So all these graphs are increasing. But if you take log x to the base half, it will be a decreasing function of x. Okay, but whatever, increasing or decreasing, as I told you, every value of log 1, any base, is always 0. Okay, so that is why x equal to 1. Okay, y is 0. All such cards, all such graphs are going to pass through 1 comma 0. That is fixed, whatever is the base. Okay. Right. So important point to be noted is that whenever base greater than 1, logarithm is an increasing function, and if the base is by chance less than 1, then it is a decreasing function of x. Okay. Now, such simple question will not be there, because you can solve it by calculator also. But just to set into the flow of properties, just to jump into the flow of properties, I have taken this question. Okay. Find the value of log 128 to the base 8. Again, I repeat, such question can't be there in GATE, because you have virtual calculator which will solve this question. Okay. Okay, but yeah, to understand some properties and techniques, I've taken this question. Log of 128 to the base 8. Okay, now there are two ways of solving this. Okay, there are two ways of solving this. Okay, what is the first way? Listen to it. Log of 128 to the base 8. Correct? That is what my question is. Okay, can be written as log of 128 divided by log 8. As I told you, log p to the base a can be log b upon log 8 directly. Okay, so this is now equal to, this is equal to log of 128. Now 128 is 2 power 7. 8 is 2 power 3. Okay, now power inside the number will come outside. So this is 7 log 2 and denominator becomes 3 log 2. Log 2 is cancelled. 7 by 3 is the answer. Okay, 7 by 3 is the answer. Okay. So just to, be saving time and solving more number of questions. Okay, I'm giving the question and I'm writing the answer. I'm discussing the solution parallelly. But if you feel, if you have that, yes, you can also get the answer of this. So maybe when I give the question, you can pause it up momentarily. You can pause the video momentarily, not an issue, okay? And you can attempt on your own and then you can replay the video. What is the second method? Now, second method, okay, log 128 to the base 8. Okay, in the second method, I'll break it again directly to the power. So 128 is 2 power 7, 8 is 2 power 3. And then as I told you, whenever there is power over the number, it comes outside multiplied. And whenever there is the power over the base, what happens? Whenever there is the power over the base, that is divided. Okay, that is divided outside. Okay, then I am left with log 2 to the base 2 and log a to the base a cancels. Okay, log a to the base a is 1 and hence the answer, as we already discussed, the answer is 7 by 3. Undoubtedly, the answer is 7 by 3 without any doubt, right? Okay, fine. Let's move ahead to the next question. Chalo, get this question and get this answer for me quickly. GATE 15 1 mark question. Okay, it's as I told you, it's a direct fundamental log question. Okay, and just allow me a minute, guys. Yes, dear. Okay, yeah. Sorry for the interruption. Okay, so we'll proceed forward now. Hope you have done the answer. Log of 5 by 7 to the base x is minus 1 by 3. So as I told you, okay, if log of b to the, it's the same concept. To eliminate the log, this time I want x, so I need to eliminate the log. So exponent will be taken. Exponent will be taken. So what is 5 by 7 then? Okay, will be, now when you take the exponent, the base of the exponent will be x. Minus 1 by 3 becomes power. 5 by 7 is x power minus 1 by 3, or what can I say is, okay, x power plus 1 by 3. Let's take the reciprocal. So is 7 by 5. This is x power 1 by 3 means cube root of x. Okay, cube root of x. So what is x? Take the cube on the other side. Okay, 7 by 5 whole cube, and 7 cube 343, 5 cube is 125. So 343 is divided by 125. 343 is divided by 125. Okay, hope you have got it. And here is the next question. Again, simple one. Simple properties they are taking first. Simplify log x to the base y into log y to the base z into log z to the base x. And again, you can use log b to the base a is log b upon log a. Na? Log b upon log a. So this can be written as log x upon log y into log y upon log z into log z upon log x. Okay. So everything cancel. Log x cancel. Log z to log z cancel. Log y to log y cancel. Answer is 1. The answer is equal to 1. Okay. Fine. Next question. Let's be moving ahead to the next question. Okay. Q power minus a is 1 by r power minus b is 1 by s power minus c is 1 by q. Find the value of. This is I've taken some GATE questions also to be discussed, but this has been asked in GATE different branches, but 2 times. Okay, and anyways, aptitude you should always practice for all branches. So GATE 16 2 marks and GATE 18 2 marks. Okay, so what is the value of a, b, c? What is the value of a, b, c? Okay, now a is hidden inside the power, b and c also in the power. Okay, so what I should do, I should take, to calculate this power, I should take the inverse of the exponent. Okay, I should eliminate the exponent by taking log. Okay, now how do I take the log? See, 1 by 1. if q power minus a is how much? 1 by r, and first of all 1 by r means r inverse. Okay, so what is q power a? Is r power 1. Okay, so what is a? Now I will take what? I will take log on the other side. What is the base of the exponent? Q. Okay, this is q power a. This is q power a is r. Okay, so what is a? It will be equal to log of r to the base q. Log of r to the base q. Clear? By the similar idea, okay. Now what is next? R power minus b is 1 upon s, or that is s inverse. Okay, so inverse cancel. R power b is s. So what is b? Now take the log on the other side. S to what base? To the base r. Log s to the base r. And similarly, we'll have the last calculation. S power minus c is 1 by q, or that is q inverse. So s power c is equal to how much? Is equal to the q. Okay. So what is the c? Again take the log of q. To what base? To the base s. Now your question is find the value of ABC. Find the value of ABC. So what is a? Log of r to the base q multiplied by b, which is log of s to the base r, multiplied by log of q to the base s. And again, just like the previous question, okay, the terms will start getting cancelled, because log r to the base q is log r upon log q. Next is log s upon log r. Next is log q upon log s, and everything getting cancelled, answer is 1. The value of ABC is 1. Good question, just using properties. All similar type or similar level questions are definitely expected. Okay, definitely expected in the upcoming exams also. Next one, let's take another one. Okay, here. And again, some things related to it, similar variety has been there in the, some of the GATE branches as well. What is the value of the expression? Okay, 1 upon 1 plus log BC to the base A, 1 upon 1 plus log AC to the base C, and next is 1 upon 1 plus log AB to the base C. Okay. Right. Now, what is this equal to? What is this equal to? 1 upon log BC to the base A. So what will I do? Okay, I will use the property log B to the base A is log B upon log A. I will split this. So log BC to the base A, I am writing log BC upon log A. Okay, everything converted to the common log. What is the next term? 1 upon 1 plus log AC divided by log B. And next. And as I told you guys, if you are getting the feeling, yes, you can solve it up. You should. Important questions. Okay, so you can pause my video. Let me go in my flow and you can match the options. You can, then you can continue with the video. 1 upon 1 plus log AB to the base C. I am writing log AB upon log C. Okay, now, okay, log A multiplied, this time simplified, log A will go to the numerator, and then denominator will be then equal to log A plus log BC. In the next term, let's multiply log B throughout. So numerator you will get a log B, and then denominator log B plus log AC. Similarly here, okay, you multiply by log C, so you'll get log C divided by log C plus log AB. Okay. Now, if you carefully notice the denominator, you can use the property log of m plus log of n is log of m into n, correct? Okay, so log of A plus log of BC is how much? Log of ABC. Similarly, log of B plus log of AC, log of BAC, it's same as ABC. Same out here, log C and log AB, the log ABC. Okay, so denominator is common. That is log ABC. What about numerator? Denominator common, the numerator will be added. But what is the numerator? Log A plus log B plus log C. Okay, and log A plus log B plus log C is again log ABC divided by log ABC. Answer 1. The value of the expression dear is equal to how much? Is 1. Okay, is 1. Okay, fine. Okay, hope the things are getting clear and sorted in your mind. Let's get moving ahead to the next question. Okay, again a good question, GATE 2015 2 marks, good question. Okay, using log as well as slight trigonometry, very slight trigonometry properties can be used here. Log of tan 1 degree plus log of tan 2 degree, etc., 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 up to log of tan 89 degree is how much? Is how much? Okay, so first of all, again, log of m plus log of n, we know is log of mn, multiplication will happen. Okay, so this if you multiply, okay, will be, okay, let me better write it here, I need some space. Let's take it here. Log of tan 1 degree, log of tan 2 degree, up to where? Up to the question is on up to tan 89 degree. Log of tan 89 degree, correct? Log of tan 89 degree. Now I will use the property tan log m plus log n is log mn. So all these terms will be multiplied actually. Log of tan 1 degree, tan 2 degree, tan 3 degree, tan 89 degree. Correct? Hai? Okay, tan 1, tan 2, tan 3, etc. up to tan 89 degree. Up to tan 89 degree. Okay. Now, this is equal to how much? Now you see, let's use some trigonometry here. When you are writing down till tan 89, dear, okay, there will be a term in between. Okay, like let me write down some more terms, tan 44, then tan 45, then there will be tan 46, then it will go up to tan 89 degree, correct? Tan 89 degree. Okay, so now see, tan 45 degree is something whose value we know, 1. Okay, now you see there are some pairs like tan 44 and 46. If you add both these angle 44 and 46, it will be 90. Similarly, tan 1 and tan 89. So 1 and 89 if you add 90 degree. Okay, 2 and here it will be 88. So 2 plus 88, 90. Okay, so like that. Okay, there are several possibilities that we need to make here. Okay, so both of them make 90 degrees. So dear, if I take tan theta and let me take another angle as tan 90 minus theta. Tan theta and tan 90 minus theta will be how much? Okay, tan theta, because both of them when you add, it becomes 90 degree. It becomes 90 degree. Okay, so tan theta and tan 90 minus theta. But we also know that what is tan 90 minus theta? Tan 90 minus theta is cot theta. And tan and cot are inverse of each other. So the result will be equal to 1. The result will be equal to 1. Okay. So these two, tan 44 and tan 46, it's like tan theta and tan 90 minus theta will be multiplied and 1. Similarly, tan 1 and tan 89 degree multiplied 1. Tan 2 and tan 88, tan 3. Hello. Yeah, sorry, there was, I think, a sound interruption. There's a battery problem. But yeah, it's okay now. Maybe it was just few seconds. So what I was telling you is tan theta, tan 90 minus theta becomes 1. And there are several such pairs, tan 1 and tan 89. Okay, 90 minus 1. Okay, similarly, tan 2 and tan 88. That also makes the pair. Tan 44, tan 46. Okay, everything becomes a pair of tan theta, tan 90 minus theta. So the answer will be 1. What is left is tan 45, okay, which does not make a pair, but tan 45 value is also 1, we know. So everything inside the log, okay, is multiplied and the result is 1. Okay, we are left with log 1, and log 1 to any base is anyways always 0. So answer for the question is 0, dear. Answer for the question is 0. Option number C. Option number C. Okay. Okay, so mostly what you're able to feel that questions are around basic properties of log. Okay, and mostly 2 markers. Mostly 2 markers. There are several PYQs you can find from the topic of logarithm and exponents, but few selected. I've some questions normal and some selected PYQs I've taken so that you understand what level of questions, and especially good questions I've selected from the PYQs. Okay, now directly characteristic and Mantis-Al. Okay, they won't ask. Mostly they're not interested in, finding the characteristic and mantis of log. But indirectly, what type of questions or tricky questions can be expected? Okay, I shall take here. So characteristic and mantissa. Okay, the integral part, okay, the floor of any logarithm is the characteristic. Okay, first let me take an example to explain you this. Okay, to explain you this, suppose I take log of 127 point, only take integer log 127, okay, and take base 10 right now. Okay, and anyways, if I have not written any base, means it is the common base. Okay, now what is log 127? I will write down its answer from the calculator, 2.1038. Okay, 2.1038 is the answer I am getting. Okay, this integral part, okay, which is also known as the floor value. See, 2.1038, what is the integral part? Is 2, na? Okay, is 2. This is what is known as the characteristic. The integral part or the floor of log, okay, is known as the characteristic. Okay, which is 2. Okay, why it is 2? I am also calling it as floor function. What is the floor function? What is the floor function? Okay, which returns the floor. Floor means integer below. Floor means below. Ceiling means top. Ceiling means top. Okay, so 2.1038, when you take the floor of it, okay, floor means below. So what is the integer below 2.1038? Is 2. Above will be 3, below will be 2. Okay, 2. And that is what I have written here. That is what is characteristic. Okay, then the decimal part, okay, is known as the mantissa. Okay, and mantissa is always positive. Mantissa will always be positive. It is only the decimal part. Okay, so what is the mantissa? The remaining part. Okay, the remaining part. Okay, that is 0.1038, the fractional part, the decimal part. Okay, that also means that, okay, the number is 2 plus 0.1038 and log of any number. Okay, log of x, okay, log of any number is always broken as its characteristic plus mantissa. Should always or can always be written as characteristic plus mantissa. It can always be written as the characteristic plus mantissa. Okay, fine. Okay, so like 2 plus 0.1038. Okay, so 2 is the characteristic part, 0.1038 is the mantissa part. Okay, now one more example and then some important conclusions. Okay, so let us find out log 51,349.26, something like that. Okay, base 10 only. Okay, so anyways to calculate log, so I am using calculator. 51349 and point, how much? 26. Okay, so log is 4.7105. 4.7105, correct na? Yeah, something approximately 4.7105. Okay, so now dear, this part, this integral part, this is what is known as the characteristic. What is the characteristic? Is 4. Okay, the integral part, and the fractional part, the decimal part, that is 0.7105 is known as the mantissa. Characteristic plus mantissa is equal to the value of the log. Okay. Now, observation. Some important observation. See, what is the characteristic obtained here is 2. And count the number of integral digits. Count the number of integral digits. 127 has how many integral digits? 3 digits. 3 integral digits. Okay, and the characteristic is 3 minus 1. The characteristic is 3 minus 1. Okay, the characteristic is 3 minus 1. Next, look into this number 51349.26 and count the number of integral digits. Only integral digits. Okay, so 1, 2, 3, 4, 5. It has how many? It has 5 integral digits. It has 5 integral digits, and see the characteristic 4, which is again 5 minus 1. 5 minus 1. Okay, so what is the characteristic? What is the characteristic? The characteristic is actually equal to, okay, the number of integral digits minus 1. Okay, it will be true for every question, every example. Okay, number of integral digits minus 1. So vice versa. Okay, what is the number of integral digits? This technique can be used to find number of digits of a number. Okay. What is the number of integral digits? Okay, number of integral digits, vice versa, I am writing it as characteristic plus 1. Okay, characteristic. See, number of integral digits in what? In any number x. Okay, in any number x. Okay, where x greater than 1. Okay, I have taken right now the log of the numbers which are greater than 1. Number of integral digits in x is equal to characteristic of what? Characteristic of log x. Okay, characteristic of log x plus 1. Characteristic plus 1. Log f base x means log to the base 10. It is results are with respect to base 10 only. Okay. Number of integral digits is characteristic plus 1, or vice versa. Characteristic is number of integral digits minus 1. Not the number of fractional digits, only number of integral digits. Okay. Okay. So all these example I have taken. Okay. I have taken for log x. Okay. Okay. Considering x greater than 1. Okay. I have taken the pattern for log x considering x greater than 1. Similarly, if I make the pattern for log x, okay, for x less than 1. X less than 1 means x is between 0 to 1. Anyways, x cannot be negative. We cannot define the log of negative numbers. Okay. So, again, some example, let me write down. Number should be between 0 to 1. Okay, that is 0. Suppose 0036, something of this kind. Okay, what is the value of this log? 0.0036. Okay, so minus 2.44. Okay, minus 2.44 approximately. Let me write the 2 decimal place. 2.44. Okay, or if you write down up to 4 decimal place, okay, 0.4437. Now, dear, what is the characteristic? What is the characteristic now? What is the characteristic now? What is the floor value now, dear? As I told you, what is the characteristic is known as the floor value. Okay, the floor. Now, minus 2.4437. What is the floor? Is it 2? Is it minus 2? Now, see, floor means, as I told you clearly, it is the integer below. It is the integer below. So, if you take the number line, okay, where will be minus 2.44? In the negative number line, minus 3 will come first, then minus 2, and then minus 1, and etc. So what is the integer below? Is minus 3. What is the integer below? That below part is known as the floor. That below part is known as the floor. Okay, so the characteristic here is minus 3. The characteristic or the floor value here is minus 3. Is that clear, everyone? Okay. So what is the mantissa then? What is the mantissa then? What is the mantissa of the problem? Is it 0.4437, the fractional part? No. Okay. The mantissa should be written so that I told you, log of x can always be expressed as characteristic plus mantissa. Okay. Characteristic plus mantissa. Okay. So let's understand this more. Characteristic is not this value. Okay. So I have taken log of 0.0036. 0.0036, which is minus 2.4437, out of which characteristic is minus 3. Now see, what can I do is, okay, I want a characteristic. Characteristic is minus 3. Okay, so first of all, let me write this as minus 2 minus 0.4437. Okay, that is why I say this should not be the mantissa. Mantissa is always positive. At the same time, the log of the number should be characteristic plus mantissa. Okay. So what I do, my characteristic is minus 3. To bring minus 3, what I do is, I subtract minus 1 and I add 1. Minus 1 plus 1 nullified. Okay, now minus 2 minus 1 is minus 3. And 1 minus 0.4437. Okay, let me do this. 1 minus 0.4437 is 0.5563. 0.5563 it is. Correct. Okay, now minus 3 is what is the characteristic I told you. And then this remaining part is mantissa. This remaining part is mantissa. Okay, this remaining part is mantissa. So what is the value of mantissa? 0.5563, not 0.4437. Got this? Okay, little bit careful here. Okay, now that means, let me write down the again answer as log of 0.0036. Okay, is okay, is minus 2.4437. Breaking into characteristic and mantissa, it is minus 3 plus 0.4463. Now, dear, note, whenever the characteristic is negative, okay, it is commonly expressed by putting a bar over it. Okay, like characteristic is minus 3. We can write down this number as 3 bar 0.5563. 3 bar means negative 3. So whenever the characteristic is negative, it is commonly expressed as putting a bar over it. 3 bar 0.5563. 0.5563. Okay. Now, dear, again one more important point. What is the characteristic? Minus 3. And look into the zeros. Okay, after the decimal point. After the decimal point, immediately how many zeros are there? Okay, the number of immediate zeros after the decimal point, 2. Okay, and your characteristic is minus 3. Discard the minus. Your characteristic part is 3. Okay, which is 2 plus 1. Okay, these are 2 zeros. Okay, after what? After decimal point. Okay, after decimal point. Okay, 2 consecutive zeros. Okay, 2 consecutive zeros. How many consecutive zeros you have? If there is any zero here, I don't care. Okay, how many consecutive zeros you have here? These are 2 consecutive zeros, and the characteristic is 2 plus 1, but negative. Negative of 2 plus 1. Negative of 2 plus 1. Okay. Let me write down one more example here with reference to this calculation. One more example. Suppose, okay, I am finding the log of 0.000043, suppose. Okay, what is the answer? Will be told by calculator, okay. 0.0000, okay, 43. Okay, 0.000043. The answer is, log is minus 0.4, minus 4.3, okay, 665. 665. Okay, now only focus on the characteristic. Only and only let me focus on the characteristic. How much is this characteristic? How much is this characteristic? Okay, is how much? It is the floor, minus 4.3665. Floor, the integer below minus 4.3 will be minus 5. Negative number again, minus 5. Okay, then minus 4 will be at the top. Okay, minus 4.3 will be between minus 5 and minus 4. So this should be the lower value, should be the floor value. So what is the characteristic? Is minus 5. Okay, only focus on characteristic. Now, how many consecutive zeros after the decimal point? After the decimal point, you have 4 consecutive zeros. After the decimal point, you have 4 consecutive zeros, and your characteristic is negative, but 5. And 5 is broken as 4 plus 1. Okay, where this 4 is coming from here. This 4 is coming from here. Okay. So, I told you a result for the characteristic, okay, for x greater than 1. Okay, let us bookmark this result separately. Okay, important result. Okay, number of integral digits is equal to characteristic plus 1, or vice versa also, let me write down, or vice versa. Characteristic is equal to number of integral digits. Number of integral digits minus 1. Minus 1. Okay, this was for x greater than 1. Okay, now if there is x between 0 to 1, okay, x between 0 to 1, then what is the characteristic, dear? Then what is the characteristic of log x? Then what is the characteristic of log x? Then it is given by what formula? It is negative. Number 1 point, it is negative always. Okay, and negative of what? Okay, number of consecutive zeros. What theory I told you? Okay, consecutive zeros after decimal point. Okay. Number of consecutive zeros after decimal point. Number of consecutive zeros after decimal point plus 1. Okay, number of such zeros plus 1, and then minus sign. That is the characteristic of log x. Okay, that means dear, okay, if I just write down one or two examples here, without, see, actual value of logarithm we are calculating from the calculator. We are doing it from the calculator, correct? If I want to calculate the characteristic of any number, okay, right, without using my calculator. Suppose I give you only the question, what is the characteristic of log 4387, okay, 0.55. What is the characteristic of this? Okay, what is the characteristic of this? Okay, so now dear, you see here, okay, now you see here, it is the case of x greater than 1. Whose log is taken? 4000 something. It is greater than 1. Okay, because it is greater than 1, what is the characteristic? Is given by number of integral digits. These are how many digits? 4. Number of integral digits minus 1 is 3 without calculator. Okay, now even if I tell you the actual value of log from the calculator, 4387.55, okay, and if I take the log of it, 3.64. So what is the integral part? Floor value 3. Okay, so without calculator, now at least you can comment on the characteristic. Okay, similarly, okay, if I give you a question, characteristic of log of 0.000568, 0.000568. Okay, now this number given to you is x less than 1. So what is the characteristic? This is x less than 1. So what is the characteristic? Okay, for x less than 1, what is the characteristic result? Number 1 point, it is negative. Okay, negative of what? Number of consecutive zeros after the decimal point, which is 3 plus 1 and then negative. So characteristic of this number, even you try from the calculator now, minus 400%. It will be minus 4. Okay, that means, okay, using these two results which I have told you, let me bookmark this also. Okay, these two results can help you directly say the value of the characteristic of log x. Okay, but what is more important, from competitive level point of view, from competitive exam point of view, okay, is the case of x greater than 1, where characteristic is number of integral digits minus 1, or vice versa. This one is more important, reverse result. Number of integral digits is characteristic plus 1. Okay, now what type of questions or tricky questions can be framed here? What type of tricky questions are normally framed here? Okay, have a look into this question. What is the number of digits in 3 power 3 power 3? See, 3 power 3 power 3 is still a small number. You can calculate from calculator, but starting with a small number. But actually, when the question comes in exam, most likely, okay, it will be a large number whose calculator answer cannot be given by calculator also, out of range of calculator. Okay, now to find the number of digits. Number of digits means number of integral digits here, because 3 power 3, what is this? This is 3 power 3 power 3. Okay, now what is 3 power 3 is 27. Okay, so 3 power anything will be integer only. So when I say number of digits, okay, this is going to be integral value, correct? So when I say number of digits, I automatically here mean number of integral digits. Number of integral digits. Okay, number of integral digits. Now, number of integral digits is given by characteristic plus 1. That's what we know. It is given by characteristic plus 1. Now, characteristic of what? Of log x. Okay, now for log, okay, what is the log I want? Log of 3 power 27, which is also equal to 27 log 3. In the exam, you have virtual calculator. You can calculate log 3 or 27 log 3. How much? Log to the base 10. Remember always. 12.88. 12.88. So what is the characteristic? Okay, what is the integral part? Is 12. Okay, and answer is then 12 plus 1. Okay, so the number of digits when 3 power 3 will be evaluated totally, suppose the number of digits 100% will be 13. 110% will be 13. Okay, 110% will be 13. Find the number of digits in 3 power 432. Now, most likely you try this with calculator. Find value of 3 power 432. It will give you out of range or math error, or it will not give you the answer of this. It's going to be a large value. Okay, it's going to be a large value. Okay, so what is the answer for this? We can solve it definitely using what? We can solve it definitely using log. Definitely using log. Okay, so what is, first of all, log of 3 power 432? Okay, 432 outside, it is 432 log 3. Okay, which is then equal to 432 log 3. 432 log 3 is 206.116. 206.116. So anyways, what is the characteristic? What is the integral part? 206. Okay, now dear, what is the result? Number of digits is given by characteristic plus 1. Okay, so answer is 207. The answer is 207. Just a second here. Okay. Yes. Okay. So, such questions, 3 power 432, you try to calculate by calculator, it's going to be out of range. But number of integral digits or number of digits I've told you as 207. Okay, again, 3 power anything will be integer. So, number of digits means number of integral digits. All digits will be integral here only. There is no chance of getting a fractional number here. See, GATE 17, IIT Roorkee, very good tricky question was made. Okay. There is no mention. See, such questions will never use the word log or anything like that. It is our techniques, how a question has to be approached. Okay. X is a 30-digit number, and that too, why it is a tricky question? Because the number is not actually given, very partially given. X is a 30-digit number, starting with digit 4, followed by digit 7. Okay, followed by digit 7. Then x cube will have. Then the number x cube will have. Okay, then the number x cube will have. Okay, so now how many digits? Okay, so number of digits means, okay, number of digits in what? The question is number of digits in x cube should be equal to characteristic of log x cube plus 1. The characteristic of log x cube plus 1. Okay. Now, what is the characteristic of log x cube? Okay, so log x cube will be 3 log x. Let's think about x. X is a 30-digit number. Okay, starting with 4 followed by 7. Only 2 digits are given. Okay, x is a 30-digit number starting with 4 followed by 7 and nothing else is given. Nothing else is given. Okay, so remaining 28 digits are actually missing here. Okay, remaining 28 digits are missing. So what is the minimum possible value of x? Okay, 4, 7. Okay, minimum possibility means all the remaining digits are 0. Maximum value of x is all remaining digits. Maximum digit is 9. So all remaining digits 9. This is minimum, this is maximum. Okay, so what I will do here is better. Okay, let me write down the x as, okay, 4.7 something into, now because I take the fractional point, okay, just after one decimal digit, so how many such decimal digits are left? 29. So into 10 power 29. Okay, 4.7 something into 10 power 29. Okay, now log of x. X is 4.7 something into 10 power 29. Okay, first of all, log a into b is log a plus log b. Log a plus log b. Okay, now this is equal to, okay, so sorry, this is not log 4.7. Okay, this is log 4.7 something. Okay, plus log of 10 power 29. Okay, now this is equal to log of 4.7 something. 29 comes outside. Okay, and log 10 to the base 10 is 1. So only 29 is enough to be written here. Okay, only 29 can be written here. Okay, so now actually we are interested in log of x cube. This is log x. We are actually interested in log of x cube. Log of x cube means 3 log x. And when you take 3 log x, it will be 3 log 4.7 plus 3 into 29, which is 87. Okay, 3 into 29 is 87. Okay, now you see. Okay, what is the minimum possibility here? What is the minimum possibility? Okay, minimum possibility of log of x cube. Okay, minimum means I told you that this is something, something, something. All the remaining digits can be assumed as 0. Can be assumed as 0. Okay, so 3 log 4.7. All other digits are 0. Okay, plus 87. And how much is this value? Let me write down. Okay, 89.016. 89.016. Perfect. What is the maximum possibility here? Maximum possibility for log of x cube will be 3 log 4.7 something something something. So maximum means all these digits can be assumed to be 9. Okay, plus 87. Okay, but now dear, look into the fractional world. 4.7999999999999. Can you not approximately write it as 4.8? 4.799999999. Up to several digits. So it approximately 4.8. So so take the 3 log 4.8 and plus of 87. This is 89.043. This answer is 89.043. That clearly shows you that log of x cube minimum is 89.016, maximum is 89.043. Okay, so log of x cube is 89 point something. Is 89 point something. That is clear. And that fractional part actually gives you mantissa. But for number of integral digits, we only want the characteristic, and hence we have got the characteristic. What is the characteristic? What is the integral part? 89. What is the characteristic integral part? 89. And as I told you, the number of digits in x cube is the characteristic of log x cube, which we got as 89 plus 1. Answer 90 digits. Okay, 90 digits, option number A. A very good question. Very tricky question, 2 marks. A very good and a tricky question here for 2 marks. Hope you have understood this. Hope you have understood this. Okay. Okay, dear. So that's it. As I told you, every Sunday we'll have Super Sunday. Okay, and as I told you in the very first Sunday also, by chance, if sometimes live session is not possible, okay, like this Sunday I had some other classes. Okay, so that is why this session was recorded. Okay, it was premiered as live, but it is recorded. Okay, it was recorded. So that's what I'll keep continuing your Super Sunday. Okay, next Sunday we'll be live only. Don't worry. Next Sunday we are going to be live only. This Sunday there was some reasons for which at 11 a.m. live was not possible. But anyways, the content you have got, the complete variety of questions of exponent and log. As like the other sessions, I'll share you the PDF in the Telegram. Okay, this is the link of the Telegram. The PDFs are password protected, and the password for today's PDF will be digit. The password for today's PDF will be digit. DIGIT. The password is going to be digit. DIGIT. Okay, note down the password. The PDF you get in this Telegram group, and you can open the PDF using the password I mentioned. Everything in small, DIGIT. That's it. This is Rakesh Silreja signing off. Bye-bye. Thank you. Stay safe and see you next Sunday on another Super Sunday. That will be live. Also, weekdays, as you know, okay, we are having control system concept sessions. So some more concept sessions we'll keep adding there. Concept sessions through PYQs. Okay, bye-bye.